Welcome back, multi-students. In this example, we are given a set G. G equals x squared over y plus y cosine z. And we are supposed to find the partial derivatives of G, which we are going to do. And don't worry, I'm going to walk you through how to do this exactly. First, we are going to find the derivative of G with respect to x. Now, it's important to remember that when we find the derivative of G with respect to x, we consider y and z constants. And constants are basically integers, if that helps simplify it for you. So the derivative of G with respect to x is going to be 2x over y. Y cosine z is going to drop to 0 because the derivative of any constant is 0. Now let's do the derivative of G with respect to y. And that is going to be negative x squared over y squared plus cosine z. And if you're having trouble visualizing all these x, y, and z's as constants, you can always momentarily assign them a random integer like 1 to help you understand better. Finally, let's find the derivative of g with respect to z. And that is just going to be negative y sine z. X squared over y will drop out because it is just a constant. And we're done! Now we're given a different problem. Suppose the temperature T at the point xyz in space is given by the function xy plus z squared minus z cubed y squared. Our problem is to find the derivative with respect to t of a particle moving along the curve described by r of t equals 3I plus sine j plus 10k. First, let's remember that ijk refers to the x, y, and z axis of our 3D area. So, the constants that come before ijk will equal x, y, and z. So, x will equal 3, sine of t will equal y, and 10t will equal z. And I know that I put k on there, but please ignore my mistake. So now let's rewrite t with our new values of x, y, and z. That's going to give us 3 sine t plus 10t squared minus 10t to the third times sine t squared. Now, remember what the original problem asked us to do. It asked us to find the derivative with respect to t of a particle moving along the curve described by r. So now we only have to find the derivative of our new function t. And now I just simplified our set t to make it more easy to find the derivative of. So you guys are in multivariable calculus, and this is a very easy function to derivatize, so I'm not going to go through exactly how to find the derivative of it. If for some unknown reason you're having trouble finding the derivative, just remember to use product rule on the very last part of the function, negative 1000 t cubed times sine t squared. And after that, you get a pretty beautiful answer.